Welcome, everyone. I hope everyone is feeling well rested and fresh this morning. I'm happy you made it. I hope the party last night wasn't... Well, I do hope it was sufficiently hard, but still enough for you to make it here, apparently. So, my name is Sebastian Olsson, and I'm going to talk about, well, the thing I just showed there, protecting CI/CD from malicious deploys, whatever that means. I work in application security at a company called TrueSec. I do most things around secure development, oftentimes around a whiteboard or reading code. Lots of threat modeling and code review and DevSecOps and CI/CD security and all that jazz. But enough about me. Let's talk a bit about your production system, because usually this is where security come in. We have something that we want to protect, right? And we have normal users using the production system and doing good things, I suppose. And then in the traditional security view of the production system, we might also have these evil attackers doing bad things towards the system, like using a vulnerability to attack the system, or leveraging stolen credentials to log into the system and do bad things towards the system. Beyond that, we might also have some types of threats that would go sort of like through the valid user. For example, a phishing attack or a social engineering attack, or someone bribing or threatening a person in order to do something towards the system. So that's also type of measure that a threat actor could take to gain access to this production system. Most usually it would be like sending a phishing email to someone and them clicking the link and giving us their credentials for us to be able to log in. Us, in this case, being a threat actor, which we obviously are not, but let's pretend. So, but there's also all these other systems that are connected to the production system. The CI/CD systems, the build systems, the things that make things happen. So usually we have a developer or a group of developers working on some sort of project, pushing source code to the source code repository, and then we have a CI/CD system picking that up, and in some way the software ends up in production. It could be that in this case we have something that looks a bit like continuous deploy, right, because CI/CD is pushing to production, but could still be that we are downloading an artifact from the CI/CD or build system and manually installing it in the production. Nevertheless, we have these systems that we somehow trust to produce the software that is later running in production. And if we can't trust that software, then we have a problem, because if it contains malicious code, then we have a bad time. So in the more modern systems, we often have the build pipelines defined even in source code, right? Well, it's not that modern these days. Most systems, well, many systems would have build pipelines defined in the source code repository, using, with, for example, pipelines in Azure DevOps or GitHub Actions or GitLab or whatever you're using, or Jenkins pipelines. So the source code repository also actually defines how we build a thing. And I suppose even if we don't use, for example, pipelines, we might still use Maven or some sort of sufficiently complex packaging system that is also doing a similar thing, where the build process is defined in the source code repository, or makefiles even. But as we mentioned then, or as we alluded to, the CI/CD system is obviously a path to production, because if you're able to deploy something from the CI/CD system to production, then you have access to databases and whatever might be in that gray blob there on the right. But a typical, well, not a typical, because it's extremely simplified, obviously, but an extremely simplified version of what a build pipeline could be something like this, a workflow in GitHub where we have 2 steps, where you build a project and then we run some tests and we deploy the thing, perhaps. who here is or has been working with a system like this and deploying directly to a cloud environment from a deploy step? Yeah, I would say, yeah, most people. I made some simplifications, of course, when I mentioned the system as being just a production or a server. That's not necessarily true if we're talking about a cloud environment. It's likely that it's more something like this, for example, that we have a CI/CD system calling out to a cloud API, and that cloud API is somehow setting a configuration on some server or a cluster or something, and that cluster is acting upon that. For example, pulling a container image from a container image repository. So we publish the container image from the CI/CD system, and then we tell the cloud environment to please pick up this container image, and then it's deployed. So we're not necessarily logging on to, say, a virtual machine to deploy anything. We're probably accessing an API with some sort of access key or other measure towards the cloud to have the new thing be deployed. And it goes even further than that, because what's popular these days, and a really fantastic thing, of course, but comes with some caveats, is infrastructure as code. So if we're doing infrastructure as code, we're doing something more like this, right? So we might send up our container image to the repository, but we're also not just telling the cloud API to deploy a new version, we're telling the cloud API to create the server. So we're, from our CI/CD system, deploying the whole infrastructure in the cloud account. Now, this obviously requires quite a lot more access rights than the previous one, because in the previous one we would typically just have the ability to deploy a new version, but here the CI/CD system through the cloud API has to have the ability to actually stand up virtual machines or stand up a cluster or do similar things. For example, using CloudFormation or ARM templates or Terraform or whatever you prefer. And yeah, that requires a lot of permissions, and I'm sure no one has ever given like a CI/CD user administrative access policy in AWS, for example, to be able to perform these type of operations. Now, really, it's very hard to lock it down. So usually you end. Did I lose? Oh. So usually you end up in a situation where you actually give the CI/CD system huge access rights to the cloud account to be able to perform these fantastic infrastructure as code operations that we want to do. So let's continue putting on our security glasses and look at these type of scenarios. And as mentioned in the text, my examples will mostly be related to GitHub and GitHub Actions, but the same goes pretty much for any modern or sufficiently modern build system. So when we think about security, we're thinking about risk in some way. And risk can be modeled in a lot of different ways. The simplest and, well, not necessarily correct, but decently correct version is to think about risk in software as a probability of a bad thing happening times the negative impact of the bad thing happening. And this is interesting because when we think about potential risk in systems, we can think about how can we reduce the likelihood of the bad thing happening, or how could we reduce the negative impact of the bad thing happening. So, for example, we could have something that is extremely probable to happen, but the negative impact is very low. If we don't have any practical availability requirements for our system, we're not hugely affected by a DDoS attack, even if it were to be likely to happen. Or a more realistic or unrealistic scenario, we could say that the negative impact of a meteor hitting our data center is very high. It's a terrible thing if that happens, or maybe even our development team. The probability of it happening is pretty low. So in that sense, we don't necessarily need to build meteor protections into our application or into our system, because the overall risk is very low. even if the negative impact is extremely high. So that's one thing to think about. And another thing is to think about how threat actors actually work in a system once they have access. And it's easy to generalize, but it's not necessarily fair to do. But let's try to do it anyway. So an attack usually goes something like this. We have some sort of reconnaissance stage where someone is trying to find the target. This could be by chance, just finding something on the internet, or more targeted, looking for companies of a certain sector that has a certain set of, that makes this amount of money each year, for example. Could be the other way around. After we've picked the target, we try to somehow exploit the target. And that's where we gain some sort of initial access to the victim. In some cases, this is turned around. It's not unusual. If we have a wildly exploitable vulnerability, say Log4Shell or something less dramatic even, it could be that we're actually trying to mass exploit something and then do reconnaissance afterwards, trying to figure out, is this an interesting victim or not? I have access to this environment. Is it worth spending time on? But in some way, it's either this order or the other order, pretty much. And once we, and again, we in this case would be a threat holder, sorry, a threat actor, which we're not, but we would then try to move between the systems and perform what's called lateral movement to try to figure out more what's in the environment to see if there's something more there for us to work on. And related to that, we would do privilege escalation, where we try to move to a higher access level. So like we have some sort of access to a system, and then we want to pivot to something more interesting until we find something that matches our interest, or something that's worth enough. And ideally, we'd want some sort of persistence for the duration of our attack. So it could be something that is going on for weeks or months, or sometimes just minutes. But in some cases, we want to deploy some malware, or somehow make sure that we can stay in the system, so we're not kicked out if the system is rebooted or something is updated or something like that. And finally, we try to do our end goal, which could be to deploy ransomware or exfiltrate data or something else, something malicious, whatever the end goal might be. In the case of espionage, maybe we would more like slowly stay in the system and exfiltrate data. And in those cases, persistence would be even more important than in a ransomware case, where we might actually deploy the ransomware fairly soon. I should avoid saying we all the time, because I'm not doing this, but other people are. So for each of these potential steps in that process, we want to reduce the probability and the negative impact. So going back to our picture we had, we might be able to separate it like this, right? So we have a few systems that are in the GitHub side of things, and the other is in the cloud side of things. It could be your own deployment or your own cloud, but usually goes something like this. On the GitHub side, we have the actions interface or the workflows, and we might have some packages that we're deploying and sharing. We definitely have our source code. We can have a bunch of other things as well. On the cloud environment side, we have, well, our cloud environment. We probably have a bunch of resources, many more than this, but in this case, we have some sort of production server that is pulling a container image repository. We probably have like a bunch of other services that aren't ours as well. That's probably from some other department or some test or some staging, maybe even. But we have a few of these. And just to try to, again, emphasize the potential for a privilege escalation and attack here, we could say that we could try to go backwards from the production system towards the evil person there on the left. So if we do that, we find some potential paths. You could go from left to the right. So for example, a threat actor could could poison the package repository and have CI/CD pick that up and that would then end up in a container image that the production environment would run. So by having certain access to the package repository, we might be able to build this attack chain or kill chain towards the production environment. Or they could potentially leverage the source code repository to poison that one and have a similar effect. Or go through the cloud API instead from the CI/CD environment. So we might use the package repository to get access to run code in the CI/CD environment and leverage that to call out to the cloud API and do things in the cloud. Yeah, you see where this is going. I actually drew this myself. I don't know if you can notice. I'm quite the artist. So some of these arrows sort of signify the initial access that we talked about. These are typically external interfaces that a threat actor might be able to directly affect. For example, the cloud API is in the cloud; it's open. If the threat actor has some way to gain to get some credentials to call out to the cloud API, they could use that. It might be that the production server is actually exposing some interfaces. Definitely GitHub is exposing a few interfaces. The arrows there in the between, they're more related to what we talked about as lateral movement or privilege escalation. So those are more paths that we would leverage on our way to our end goal, which is to do something bad in the production environment in this case. So this is a very difficult thing to solve, and I'm sad to say we're not going to be able to solve it fully because there's many layers to it, but today we're going to focus on the CI/CD system and how to potentially avoid some problems there. So one way to solve it is to look at each link of this chain and try to make sure that each is authorized and authenticated correctly so that it can't be abused, so we don't have any unauthenticated cloud APIs or something like that. Another way of looking at it is to do more of a full supply chain security setup where you sign each step of the build process and use, for example, bills of materials and then verify the content of those in the runtime environment so that each time you deploy something, you make sure that it has been built in a certain way using cryptographic proofs of that. Although still, those proofs are most often generated in the CI/CD system. So even if you use those, you still might need to make sure that not anyone can log on and gain admin access to your GitHub account, because then they can affect the proofs. So this is still very relevant. Another thing that we can do is, like I said, the first is our focus today, and the other is taking it to the next level, but you still need to do what we're talking about today. The third one is something that I don't think a lot of people are doing. I think I can ask it because I think probably no one is doing it, and that's actually monitoring your CI/CD system, at least GitHub. Is anyone here looking for malicious events in their GitHub security logs, or has ever looked at their GitHub logs? Or no? No, that's fine, because no one is doing it. They are there, and in some cases it's possible to ingest them into log systems, etc. But it's safe to say that no one is looking at what's actually happening in these systems. Possibly we will in the future, but there might be some weird things that we want to react to in our CI/CD systems or our deployment environments. I mean, as an example, you might have a service that you're using to deploy or build your application that you're hosting yourself. You might have your own runners, for example. And even in those cases, I would say it's fairly unusual to have very much monitoring of that environment either. So if the threat actor wanted to stay in that system, it should be decently easy. But let's take it to the next level security-wise. So in this case, we're going to try to think as a potential attacker. I been sort of doing it because I couldn't avoid it previously, but let's do it all together. So now we have our happy pirate here trying to take it one step further. So let's look at a typical GitHub case simplified, or a typical CI/CD case simplified. So the user, we talked about the fact that the source code repository could be a path towards production through CI/CD. So that usually means that a single Git SSH key is a path to production, right? So if you have access to an SSH key on a developer computer, you can push to the source code repository, CI/CD will pick it up, and it might end up in production. And that's how it works, right? So obviously this should be interesting for someone to gain access to. Do you recognize this as a typical setup? Yeah. So how do we protect this developer computer? Because obviously the developer computer is very important here, or rather, how do we protect this single token that is used to be able to access production? Typically, as we see to the right, it might be that we look at classic account security things, like having unique passwords, using multi-factor authentication, maybe having endpoint detection on the device and anti-malware or antivirus things. We might use single sign-on with advanced, expensive risk and fraud detection algorithms to try to figure out if someone is using the account on the wrong device. More likely, it's going to react and say that you're coming from a new IP or coming from a country that you haven't before. So it's often more IP-based and not as cool risk-based fraud detection as the vendors might say. These kind of things often happen due to, for example, a reused or a leaked password, or as I mentioned previously, someone attacking a person through phishing. So sending a phishing email, for example, and having them enter their login credentials into a fake site, then the threat actor might be able to use those credentials to access the environment. Or it could be malware on the device, although it's a bit less likely, but could definitely happen. And we have it with software supply chain attacks where, for example, malware might be added into a third-party dependency, and that dependency could then, for example, try to steal SSH files or private keys or other secrets from the system, assuming that's possible. But there's an interesting thing, especially when it comes to GitHub, because GitHub is, or at least used to be, a social network. I say used to be because I saw a bit from the GitHub Universe conference, which started the other day, and they've rebranded to more of an AI development platform these days. But at least it used to be a social network, pretty much. So we want to collaborate on code, and people want to keep their profile throughout, well, eternity, I suppose. So this leads to an interesting situation because it's very common when we come into an organization to see that all the developers are using private GitHub accounts. And I'm not going to say that that's wrong. I'm going to get to that. But this is a very common situation, which is maybe not super intuitive to the normal information security professionals, that this is the case. Has anyone seen this, that everyone is using their private GitHub account to do work stuff? Yeah, it's almost the norm. And it's something that GitHub isn't saying you shouldn't do, because they wanted to push this social network thing, and people want to have the little squares on their GitHub profile for their next job. So I can understand why it is like this. But there's an interesting angle here. Can someone guess what it is? What the attack path would be here? Yeah, there's private laptops and computer. Yeah, I suppose. Yeah, the pirate person is there at home. That's creepy. No, so exactly, that's true. So it's the same account, and it's usually also the case that you would have an SSH key, for example, on a private device or some other third-party device that has access to the corporate resources, which is usually totally unacceptable in any other environment, but developers are allowed to do this. Probably, I mean, it's intuitive. It's like this. When I talk about it with developers, like they are smart people. It makes sense, but they usually never thought about it that way, right? So they want to use the same account, and they get the organization, their account added to the organization. But that also means that when they're logging in somewhere else, they have access to all the corporate resources, and maybe even access then to just push to production to the source code system from their private device that they're doing other weird things on. So from an information security perspective, this is usually not great. It's a technical term. The thing is, like, even if those were separate SSH keys, they still go to the same account and they have access to the same stuff. So it might be that you would need to think about this. Some organizations would then obviously add SSO. So you can have SSO on GitHub where you still log on to your private account, but you also have SSO to reach the corporate resources. It's a sort of weird setup that they have in order to make sure that people still use their private accounts. So you log on to your private account, and then when you try to go to the corporate resource, you might need to do the SSO dance. Although in many cases you don't actually need to do it, because many organizations enable SSO, but they don't enforce it. So you can choose if you want to use SSO or not. So in order to sort of fix this, you need to enforce SSO, and that would require the users to actually configure which SSH keys and access tokens, etc., should actually have access to the corporate resources. So if you have an enterprise, if you have a GitHub organization that you've configured to enforce SSO, you wouldn't then be able to use the SSH key on your private device, because that SSH key hasn't been blessed with the access rights to the corporate resources. There's still a risk that you would give access to the wrong key, and there's still risk that someone would steal your login when you're logging into SSO and then bless another key. But like, to be able to do this, you need to be logged on with SSO, right? So you could only bless an SSH key while logged on to SSO. Sorry, I hope that made sense. That was SSH and SSO, but I think it's not that complicated, I think. I'm making it more complicated than it is, I suppose, which is my job. So that's one way of doing it. The other way of doing it is, of course, to have separate accounts instead, to have separate accounts for your company access. You could either do that manually by setting up these accounts and not sharing them, or you could have accounts that are just created through SAML SSO. So the account is sourced from the SSO endpoint. So this is a very interesting potential path to lose access to all your company resources, right? If you get malware on your private device, you might lose your GitHub SSH key, and then the threat actor might do bad things to your employer environment, which could be a bad day. So I would recommend never using the same account unless you have configured it to enforce SSO in this way, and make sure that you're not using keys that have access to the corporate resources from your private device. So we have some sort of user access in this case. We've gained access, again, the threat actor, we've gained access to the system. Now we might want to escalate. So the first thing we could do is to look for secrets in code, and this is very effective. So if you have access to a source code repository, you can find massive amounts of secrets in it normally. It doesn't have to be this obvious. It's super obvious here. We have the deploy key just laying in the build file. But it could be pretty obvious. And it's not just deployment files. We could find oftentimes a lot of SaaS tokens for different SaaS services, other cloud APIs, access keys for AWS, what have you. And those should not be in source code, because that means that they are leaking beyond our control. And an interesting thing is that if we're using Git, even if we delete it from source code, it's still there, right? So it can still be found if you have access to the repository, and it's also spread throughout the system. So it's not enough to remove it from code. Even if you force push it, you need to actually rotate the secret and not have it in code. The first step and typical step would be to make sure that the keys are only available in the environment where we're using them, not in code. So in this case, for example, we would add them as secrets. I'm gonna come back to this, but we're gonna start by adding it as a secret in GitHub, so that when the code is running, the secret is available in GitHub, but it's not available on the developer computer because the developer doesn't need access to that secret directly. You've probably seen this or something similar to this. So what could the threat actor do then? Well, the threat actor might be able to push directly to main and have the thing build instead, because they probably have build rights. So in this case, we have a threat actor that has access to your GitHub account. They can push to main because that's what you do. And then the thing builds in production, and yeah, it's not game over, but it's a bad time. So how might we mitigate this to make sure that the threat actor can't push directly to main and have it run in production? Yeah, that's true. We could have merge or branch protections and require reviews, right? So we need a colleague here down to the left who verifies that this is okay. We can push it. But there's some other things we can do then. One thing we can do is to push to an already approved PR, especially if that it's approved for the same user that we have gained access to. Because that approval is often still there if we push a new commit. So we can just add a commit and hope that it gets merged soon, or maybe merge it. There's usually a bunch of approved PRs out in any organization that we just tack some bad code onto. If we want to. We could fix this by requiring a review from the least intrusive way is to require that someone other than the last committer actually reviews before you merge. Or if you want to go all the way, you can enforce the setting where you dismiss stale pull requests when there is a new commit. The problem with that is that if you do some sort of rebase or merge operations or similar, you would again need to review it. So the upper one is slightly less secure, but also less intrusive. Another thing that this threat actor might do is actually to have some sort of robot approve the PR. And this is one of my favorite ones. This is a bit esoteric, so it's less likely that it's going to happen, but I think it's a fun thought exercise nonetheless. So it turns out that in many cases, GitHub Actions has Git permissions, including the ability to create and approve pull requests. And that is the user that you get a token for in your pipeline. So you get a GitHub token in your pipeline, and that GitHub token, in some cases, has access to call the pull request API and approve the pull request. So you can do a pull request that's just self-high-fives and says this is awesome, I approve it. Or rather, the GitHub user approves your pull request. So your pull request can approve itself, which is super handy, of course. For new repositories, this is no longer allowed because it was terrible. But if you've had the repository or organization for a while, it could be that the normal GitHub token is still allowed to approve pull requests. Similarly, there could be a bunch of personal access tokens added as secrets or added into the system, and those personal access tokens could definitely also have the rights to approve a pull request. This one is fun, I think. It's not just me. I think that this one is a bit fun. Yeah, but it's solvable. But it's a weird thing. So we talked about secrets. The thing about secrets in GitHub, as in many secret systems, is that they're not really secret. That's the bad thing. So I don't know if that's possible to read this from the GitHub documentation. Any user with access to your repository has write access to your repository has read access to all secrets configured in the repository. So if you actually have any reasonable access to this repository, you can either extract the secret or run a pipeline, a pull request that just steals the secret. So the deployment secret is not protected by the branch protection, and that's way more convenient for a threat actor to actually just steal the secret and go directly to the cloud API without going through this silly pull request thing that I did earlier. It's much more convenient to just steal the secret. So the simple solution is to use what's called environments in GitHub. So you set up an environment and you add the secret to the environment instead of to the organization or the repository. And then you set a requirement on the environment that this environment is only available on this branch. So you attach the environment to the main branch, and then you put your review requirements on the main branch. So that way the secret is only released on workflows that are running on that branch. And in order to reach that branch, you need to pass review. Hope that made sense. So that way you achieve what people usually think they have with secrets. It's that it's only available on the actual branch that needs them. You could also look into secretless deploy roles, which is the coolest thing. But I need to go through that fast. But OpenID Connect is something you can use. For example, in this case in AWS, you can set up an OpenID Connect provider and say that each time GitHub calls out to your OpenID Connect provider, if they come from org/repo, blah, 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 this branch, they're allowed to assume my role. So in your actions, you do, I want to assume this role, and through magic, you get those permissions in the cloud account without a secret. It's pretty nifty. You can do the same for other cloud environments as well. So you set a trust between GitHub and AWS, and then you can just select the roles you want to do. You can do more advanced configuration as well. So you can say, like, when you come from this workflow, etc., then you're allowed to assume this role and do whatever you need to do. Don't forget that admins can bypass most of these settings, and a lot of users are running as admin on GitHub. So like maybe the whole team is running as admin. So all of the stuff that I just mentioned is pretty moot if everyone can just disable it. So don't be admin all the time is the solution there, probably. In some cases, you should probably have a separate admin account. Self-hosted runners. Make sure to read about the security of those, because they are not isolated the way other runners are. So we talked about persistence and privilege escalation. If you're just using a VM where you have runners being scheduled, the runners can affect each other, like so they can plant malware or steal secrets from each other, etc. So in those cases, you need to either orchestrate just-in-time runners, which is a pretty new thing. There are projects for this, or isolate runner groups. So you have separate runners for separate branches and separate jobs. Make sure to not use the same runner for everything, because then all jobs, including PRs, have access to everything. And this is different from if you're using the GitHub-hosted runners, which they probably want you to use because they make money from that. Because those are new virtual machines every time, so those can't steal data from each other. But if you're just using the self-hosted runner binary, that's not the case. Yeah, this is not as fun, but you can often publish a malicious package. So make sure to configure the package repository if you're using GitHub to make sure that not anyone can publish a package to your repository, because otherwise people might just do an update on their npm or whatever and get the latest version, which is malicious, and the publish there to the package repository is usually not protected by branch protection. So you can often just, if you have write access to repository and you have a package that is repository bound, then anyone with write access to repository can write a new version of that package that is later then used. So we looked at the probability and to some extent negative impact, or at least more negative impact than the probability. The user has access to a key now, which is bad, so we need to focus even more on the negative impact because the bad thing has happened. And the simple thing is deployment secrets are often too powerful, so make sure to scope the tokens so they can't be used to attack some other service. And this is very hard with infrastructure as code. So probably, for example, in the AWS example, it's even more important to use separate AWS accounts if you're using IAC, because otherwise you might be able to just affect everything with your likely administrative access permissions. So I'm running out of time. I thought I had so much time. This is a fun topic for me. So some recap. Manage accounts. Make sure to separate private and work and avoid daily admin privileges. Manage secrets. The normal secrets aren't very secret, so utilize environments, or even more nicely, utilize OpenID Connect. If you rely on branch protection for security, make sure that they actually work. So go into the security settings and make them a bit more strict. Infrastructure as cool. Infrastructure as code is really cool, but don't make all the builds have the master key to the whole cloud environment. You need to separate that somehow. It can be really complicated, but try to make it simple, for example, by isolating accounts for the different services. Or come up to me later and we can talk about some potential solutions to it. So I want to just leave you with the actual documentation for security hardening for GitHub Actions is pretty decent. It's pretty good, actually, so I would recommend that. And if you're interested in the general idea of supply chain security and protecting the whole thing, check out the Salsa project, which is many presentations of their own. So thank you very much.